As we begin to look at Chapter 2, we're going to be solving equations in Chapter 2 in comparison to simplifying expressions that we did in Chapter 1. One of the things that we want to do when we're solving an equation is we're going to try to isolate the variable or the x value in each of our problems. So here we have a problem x minus 4 equals negative 9. We want to try to get the x minus 4 isolated so that just the x is on by itself. And to do that, we undo the problem. So to undo a minus 4, what we're going to do is we're going to add 4. Now, just like when you're passing out candy to someone or a group, you have to add 4 to both sides of the equation to make sure it's balanced, just like a seesaw. So here I show adding 4 to both sides. Well, now we just simplify. Negative 4 and positive 4 cancel. Negative 9 and positive 4 make negative 5. So my answer is x equals negative 5. Now, one of the things that we want to make sure that we do as we're working through these problems is that we check our work. So to check our work, I replace the original problem with a parentheses where I had an x, and I stick in the value negative 5 there. So negative 5 minus 4 is negative 9. So it checks, and we know we have the problem correct. So whenever you have the problem checked, check it off and circle your answer. I'm going to want you to do this on your homework tonight. On your left-hand side of your problem, do the problem. And on the right-hand column, I'm going to have you do your check. Let's look at problem number 2 over here to the right. Now we have m plus 5 equals 18. The opposite of plussing is minusing, and so I'm going to subtract 5 from both sides. And so here you see I've subtracted 5 from both sides. Well, 18 minus 5 is 13. 5 plus negative 5 is 0. By the way, do you remember that that is the additive inverse property? Numbers that add to 0 are called additive inverses. So my answer is m equals 13. Now I realize you probably knew that very simply, but remember the things that we're trying to learn today is the process, not necessarily that the answer is 13. Now let's put our number 13 back into the problem. Notice I use parentheses when I put my number back in. So 13 plus 5 obviously is 18, so I check it off and I circle my answer. Once again on your homework, you're going to do the problems on the left-hand side and you're going to do your check on the right-hand side. Let's look back now at problem number 3. Here we're supposed to find the value of x for this diagram. And the value of x could be illustrated by the following problem. We have to understand what these lines mean on the diagram. Whenever you have a diagram and there's lines on each of the diagram, little hash marks, that means that this segment AB has the same length as this segment AC. Those are called congruent. So, if this side is congruent to that side, then 16 equals x plus 3.1. And that's what I've written down here. X plus 3.1 equals 16. Well, now we have a problem just like number 2. To eliminate the plus 3.1, we're going to subtract 3.1 from both sides. Subtracting 16 minus 3.1, that's 12.9, and that's our answer. Let's see if it checks. Replace the x with a parentheses and add 3.1. Does it equal 16? Well, it sure does. And so here you see I've checked it off, and I'm going to circle my answer. Let's look at problem 4. Now we have a fraction in the problem. And I've noted off to the right the LCD is 12. Hopefully you know between 3 and 4, the least common denominator, the LCD, is 12. How do we solve this? Well, to do that, we multiply each part of the equation by 12. And so here you see on my next step, after subtracting 2/3, I did this one differently. Let's subtract 2/3 from both sides. That multiplying by the LCD is something we're going to do in the future. I'm sorry. So we subtract 2/3 from both sides, and here we have 1/4 minus 2/3. Now we need to get that LCD. The LCD is 12, so I multiply 4 times 3 and 3 times 4. Notice it's 3 over 3 and 4 over 4. That gives me 3/12 minus 8/12, which is negative 5/12. So here's my check at the bottom. Let's take a look at how we went about and checked this. I replaced the x value at the top with parentheses and negative 5/12. Plus 2/3 equals 1/4. I'm going to change everything to twelfths. So here's twelfths, twelfths, and twelfths. 3 times 4 is 12. So 2 times 4 is 8. 4 times 3 is 12. So 1 times 3 is 3. And does negative 5 plus 8 equal 3? It sure does. And so my answer truly is negative 5 over 12.